Okay. All right, so we're starting 8.3. It's trigonometry. All right, we've had lessons 8.1 and 8.2. Y'all have a quiz over these 3 lessons Monday. I will, on break, make a copy of a review that we will do on Monday. If you want it today, though, you can get it from me, or tomorrow, okay? The review that I'm going to go over, like if you want to see it like tomorrow or review this weekend, you can get it from me, and then we'll still go over it on Monday before the quiz. So we're looking at trig ratios is what they're called. It's sine, cosine, and tangent, okay? So you have a right triangle, right? That's what we're dealing with in this chapter. And what's the hypotenuse? Is it A, B, or C? C. C is the hypotenuse. It's always the longest side, and it's always across from the right angle right here. So C is the hypotenuse, okay? Depending on what angle you start from, you're looking at opposite and adjacent. Do y'all know what those words mean? Opposite is like what's across from you. Okay, that's on the opposite side. What does the word adjacent mean? Nope. It's coming back. It's coming back on. Adjacent means next to you, if it's adjacent. Okay? Yes, no, we kind of get that. So, they tell us to look at angle A. All right? We're going to start at angle A. I'll put that little cursor right here. Here's our angle A. So, you're going to have to memorize these, and I'll show you a way to memorize it. Have y'all ever heard of SOHCAHTOA? Okay, y'all haven't. That's fine. I'm going to show you how to remember this in a second. But sine of an angle is the opposite over the hypotenuse. So you just have to start at this angle, and which one is opposite of it? Angle A. Side A. And what's the hypotenuse? C. Y'all already said that. So you would put A over C, and that's your answer. That's all it is. You just have to remember these kind of formulas, all right? Cosine, that's another trig function, and tangent. Cosine is adjacent over hypotenuse, and they want me to, again, start at angle A. So if I'm right here, what side is adjacent to it? What side is next to it? B, and the hypotenuse is C, okay? On this triangle, every time the hypotenuse is C. Do we kind of see that? Then tangent, if you're looking at the tangent of angle A, that means you start at angle A, and it says opposite over adjacent. So what's the opposite side? Little a. And what's next to it? What's adjacent? Little b. Those would be your answers because they're going to have numbers. Okay? And I'm going to show you how to remember that. Let's pretend for a second that we were looking at angle B. What if they had a B right here? Then that would be where I start at, right? So the sine of angle B is opposite over hypotenuse. What's opposite of that? Little b. And what's the hypotenuse again? Over C. So it depends on what angle you're at as to what's opposite and what's adjacent. Does that make sense? Kind of, a little bit. We'll start a problem in just a second. If I have, did it come back? Yeah. SOHCAHTOA, this is how you will remember which one's opposite and adjacent and all that. And hypotenuse. Let me get my page out. It's this little word right here. SOHCAHTOA. SOHCAHTOA. So like for ACT or any kind of testing purposes, if you're doing trig, right triangle trig, that's the word you need to know. And it basically says that the sine function is what? Opposite over hypotenuse. The cosine function is what? Adjacent over hypotenuse. And the tangent function is what? Opposite over adjacent. That's all you need to know. And you will see this so much, sounds like almost like an Indian word or something, right? SOHCAHTOA, that you'll have that memorized. That way you don't just memorize little individual formulas. Just memorize this word, write it down, and then you'll have all the formulas right there. Okay, so they give us, let me just draw this triangle that they have. Here's our right angle, and they call it GRT, and 17, 8, and 15. So they want me to find the sine of t, the cosine of t, and the tangent of t. So I'm going to write those down. The sine of t, I'm going to find that ratio. The cosine of t, that ratio, and the tangent of t. I'm going to find all those. So what letter am I starting at? T. That's my angle t. So if we're going to find the sine of t, it's what? Opposite over hypotenuse. So what's on the opposite of t? 8. And what's my hypotenuse? That's my answer. 8 over 17. That's my trig ratio. Now let's try cosine. It's a different function. So again, I'm starting at t. What's the cosine of t? Adjacent, the next two, is 15 over the hypotenuse is 17. And then finally, the tangent is opposite over adjacent from this angle t. Which one's opposite? 8, and then adjacent was 15. 8 over 15. So does everybody understand how to read this word right here? SOHCAHTOA. Yes. Let me see if they have another one. Okay, now they want us to use the same problem. And they said, okay, they want us to find the sine, cosine, and tangent of angle G. So now I'm going to have different answers because I'm starting at a what? A different angle. All right, so if I start at G, what's the sine? Well, it's opposite over hypotenuse. 15 over what? 17. That would be that answer. And y'all, if sometimes you can reduce, like if it was 4 over 8, what would that be? 1/2. Like, so you can reduce fractions. On this problem, you can. All right, what's the cosine of G? 8 over 17. Adjacent over the hypotenuse. And finally, the tangent of angle G is opposite over adjacent. That's 15 over 8. And there we go. How is that? Not too bad. So what I want to do, they give us some, of course, with square roots. So let me find one with a square root. I'll do one more problem. Let's look at number 12 in your book. It's MKL. And then y'all can do y'all's first few on your sheet. M, K, and L. This is 7, 9, and 4 square root of 2. And they want us to find, they said M, but let me pause this for a second and see if I want to do sine, cosine, or tangent. Okay, they did angle M. I want to find angle L. The reason is because I want to have a square root in the bottom, because on your worksheet, they have a square root in the denominator. All right, so we're going to find the sine, cosine, and tangent of angle L. Your book did angle M. All right, so if I start at angle L, what is the sine? 7 over 9. That's opposite over hypotenuse. Okay, that one's fine. Now, what's my next thing? Cosine of L is 4 square root of 2 over 9. That's adjacent over hypotenuse. That's just fine, right? The 4 and the 9, they can't reduce. Here's where it's like this on your worksheet. I'm going to find the tangent of L, and it's opposite, which is what? 7 over 4 square root of 2. What's wrong with that? You cannot have a square root in the denominator, okay? So what do you have to do to move that square root? Multiply by it, right? We're going to multiply the numerator and the denominator by that number, the square root of 2. There's nothing wrong with that 4. It's just the square root of 2. So I multiply both the numerator and the denominator. So 7 times the square root of 2 is what? 7 square root of 2. That's 7 times the square root of 2. Now, in my denominator, I would have 4 times, what's this? What's square root of 2 times the square root of 2? 2. That's just 2. That's why you do that. The square roots go away. What is 4 times 2? 8. So, again, you multiplied so the square roots would go away, and it just becomes a 2. 4 times 2 is 8. Do y'all understand that? Because that's like number 2 and 3, they both have a square root, just like that. So you'll have to do that one time on those problems. Okay, so for now, you can do 1, 2, and 3, and they pick letter X, your angle X, okay? What did y'all get on one of the problems? I know y'all had two, I think, that had the square root.
Isn't it, if it's in the numerator, you can't?
In the numerator, you leave it alone. It's fine. Like, what is your answer? Tell me what your answer was on one of them.
Well, were all of them in the numerator?
The square roots? No, There was a problem where the square root is in the denominator. Y'all tell me one of the things that you got to see if we need to simplify it. None? Y'all don't have any?
I already simplified square root of 3 over 24.
Okay, 8 square root of 3 over 24. Oops, square root of 3 over 24. All right, on this one, yes, you can simplify. Okay, because ignore that square root of 3, but what do we have? We have 8 over what? 24. So divide them both by 8. So I would get
Where did you get 24?
1 square root of 3, and what's 24 divided by 8?
8
3.
times 3 because you multiplied it by 8.
Look.
3 times square root of 3.
Number, I'm guessing this is number 2. Was this, which one was this? Yeah, where did you get? Oh yeah, you had 8 over 8 square root of 3. Let me start at the beginning. 8 over 8 square root of 3. This was the tangent of x on number 2. The tangent of x. This is what y'all should have gotten, right? Opposite over adjacent. Okay? If you wanted to, you could go ahead and cancel out your 8s, but you didn't have to. We can wait and cancel out in a little bit. The square root of 3 cannot be in the denominator, correct? So what do we have to multiply by? The square root of 3. You just multiply it by itself. So what do we get in the numerator? 8 square root of 3. That's where that came from. So 8 square root of 3. Now in the denominator, that ends up being what? 8 times 3, which is 24. Some of you may have left it like that, but you should be able to see that 8 over 24 should reduce, right, to 1/3. You can put the 1 if you want. I normally don't. But look, you could put 1 square root of 3 over 3. I didn't put it on my answer. I just put square root of 3 over 3.
Wait, can you do the cosine?
Wait, yeah, I'll do the cosine. What, Hayden?
This one number 2.
That's for number 2, the tangent.
Cosine. Okay, nothing.
Okay, number 2, the cosine, or number 3, the cosine of x. So I'm looking at number 3 on your paper. The cosine of x, and if you're looking at your paper, cosine is what? Adjacent over hypotenuse, right? So that is what? 8 over what? 12. I'll put 8 over 12. And then you can reduce that, right? You can put it in your calculator to reduce it and press math enter. Or divide them both by what number? 4. So what do we get? 2/3. 2 over 3. And that's your answer. It's a ratio. It's written as a ratio. That's a trig ratio. How do we feel about these?
Wait.
Yep.
Do the rest of them weren't like that though, right?
What do you mean weren't like that? On the sine of x on number 3, you can reduce that one. Did y'all reduce the sine of x on number 3?
I mean, I got that 8.
Oh, yeah.
Sine of x, no, that was a cosine of x. The sine of x on number 3, what did y'all get for that answer?
1 over 3.
Well, okay, what's the opposite? 4 square root of 5. You were ahead of me a little bit. No, that's fine. That is kind of what I was asking for, the answer. That's your opposite, and what's your hypotenuse? 12. Can y'all see that there's something that needs to be reduced there? 4 over 12. It can be reduced. Did y'all reduce it on your paper? You have to reduce.
Can you do the tangent?
Would it be?
Well, I'll do the tangent in a second.
1 square root of 5
Yep.
over 3.
1 square root of 5 over 3. And if you write the 1 in front of the square root of 5, that is just fine. I usually don't write the 1 in front. But if you wrote 1 square root of 5 over 3, that's the right answer. 4 over 12 reduces to 1/3. Is everybody good with that?
No.
Yeah.
On the reducing or on the... If I gave you the number 4 over 8, what does that reduce to? 1/2. If I give you the number 4 over 12, what does that reduce to? but divide them both by 4, and you get 1/3. That's the same thing I'm doing right here. The only difference is I have a square root of 5 that I have to keep.
So you just leave it there?
Yeah, it has to stay there. So I basically have 1/3. You can put the 1 if you want. That reduced to 1/3, but I still have a square root of 5 right here. It doesn't go away. All right, so all you're doing is reducing a fraction if you can. Let's keep going. Was there one other?
Was
Yeah.
that the only ones that maybe?
Oh, somebody asked me about tangent. Tangent needed to be reduced. You asked me about tangent, Madison. It needed to be reduced. Did you reduce that one?
I did, but on number 2,
Because the tangent of x on number 3. Thank you so very much. See, and it didn't take long. The tangent on number 3 is opposite over adjacent. So you have 4 square root of 5 over 8. Did y'all get that?
Is it square root of 5 over 2?
Yeah. You just reduce. It reduced to 1/2. But your square root of 5 cannot go away. So you were right. Square root of 5 over 2. All right. I think we're getting better. Y'all, please remember, this is the first time to deal with trig functions, so if you don't understand it completely today, it's okay. On Monday, when you come back, we will have a review, okay? We will review every study guide, and you will pick it up even faster then. All right, let's keep going to the next type of problem. I won't do that one just yet. Let me draw a triangle. It's looking like the next little section on your worksheet. Notice that they give me angles now. I know that that's a right angle because that's what we're dealing with, right triangle trig. They tell me that this little angle, it's probably hard to see, but that's 54 degrees. And then they tell me that this side is 17, and now I'm looking for another side. And we have to use those 3 trig functions, one of them. You have to figure out which one to use, and that's the hardest part. So you know it's sine, cosine, or tangent. SOHCAHTOA. So you start at your angle. What's my angle that they give me? 54 degrees. Does everybody see that? They give me 54. So it's giving me opposite over the what? Hypotenuse. Does everybody see that's the 2 things that it's telling me? The opposite over the hypotenuse. Which function is that? Sine, cosine, or tangent? Sine. So that's you have to figure out which one am I going to use. Well, it gave me opposite over hypotenuse. That's sine. So I'm going to write that. The sine of 54, because they gave me my angle, right? I'm not calling it a letter. They gave me the angle, so I'm plugging that in. Equals, what is my opposite, y'all? W over, what's my hypotenuse? 17. Does anybody not understand that part?
Well, that's for x.
We're solving for W. We're not looking for an angle this time. We're not looking for a ratio because they tell us our angle is what? 54. So I'm going to write that for my angle. The sine of 54 equals the opposite, which was W, over the hypotenuse. How would I solve for W? Just ignore the whole sine thing. What would you normally do to solve for W? What are you doing to it? You're dividing by what? 17. So how would you solve for W? You would multiply by 17, both sides. So watch. Over here, I would multiply by 17, and that cancels out. And what am I going to do on the other side? Multiply that by 17. Guess where you can put all that? In your what? Calculator. You can type all that in your calculator.
918.
And then it'll tell us our answer. So over here I get W. And in your calculator, please go to the mode on your calculator real quick. Everybody take out your calculator. There is a mode button. It's right there. Now, mine's in radian. Does everybody see how mine says radians? It does not need to be in radians because we're dealing with 54 degrees. So I'm going to go over and make sure I press degree. Press enter on degree. And yours probably was already on degree mode. It wasn't. So now is it on degree mode? That's going to give you the right answer now, okay? I will tell you if we ever need to go back to radians.
How do I get out of it?
Yeah.
Now just press second mode. That's the quit button. Now we can type in this right here, 17 times sine of 54. So I'm just going to type that in. 17 times, and then our sine button, do y'all see it on here? It's S-I-N. Yep, sine. So 17 times the sine of 54. And did everybody get 13.75 or whatever? They rounded to 13.8 for their answer. Okay, so we'll round to the 10th place. So 13.8. How do we feel about that? It's just figuring out what your trig function is, solving, okay, and then put it in your calculator. Let's do another
I
one.
think the only hard one is putting it in your calculator.
That's the hard part, is putting it in your calculator?
It's not figuring it out. It's pretty easy figuring it out.
W, 28 degrees, and this is the number 1. Okay, this one, my angle is 28 degrees. So I need to figure out what trig function I'm using. Let's see, is it sine? Is it opposite over hypotenuse? No. Let's see if it's cosine. Is it adjacent over hypotenuse? No, I have no hypotenuse. So what's left? Tangent. So I'm going to write the tangent of 28 because I know my angle.
Wait, Miss Matt.
Yes.
What did you do?
Okay, the first step is to figure out, am I using sine, cosine, or tangent? So I always start with, well, I can tell it's going to be tangent because there's no hypotenuse. That's the only trig function where you don't use a hypotenuse. But say you don't know that, just start with sine. Try to use that. The sine of 28 equals 1 over, I don't have enough information. Okay, let me try the cosine. The cosine of 28 equals the adjacent W over the hypotenuse. I don't have that. I don't have enough information. The last thing for me to try, the tangent of 28 equals opposite 1 over adjacent, W. That one's the one I have all the information. So I'm going to put 1 over W. Now this one's weird. On the last one we multiplied. So a lot of times we'll just multiply and have our answer. This one's a little bit different, y'all, because the W's in the denominator. So there's this trick where when your variable's in the denominator, you can just switch sides with it. Okay? I'll show you why in a second. But basically, it's just W equals 1 over the tangent of 28. Do y'all see how I just switched? When your denominator's in the bottom like that, you can just switch it with what's on the other side. Do you want me to show you why? Okay, I'll write it over here. The tangent of 28 equals 1 over W. If I was solving this out, this is my shortcut. Just memorize that you can do that. But if I solve... Huh? No. We have to divide that in a second, and it'll be our answer. I would have to multiply by W to get that out of the denominator. So those would cancel out. I get a 1 over here, and then over here I have W times the tangent of 28. Now my W's out of my denominator. Then what do I have to do to get the W by itself? Since it's being multiplied to the tangent, I would have to divide by the tangent of 28 on both sides. So W equals 1 over the tangent of 28. Do you want to have to solve that out every time, or do you just want to memorize this little trick? In advanced math class, they just called this switcheroo. I don't know. They just, when the variable's in the denominator, you can just switch them. That's it. Instead of working this out every time when the variable's in the denominator, you can just switch it, and that'll be what we get for our answer. So type that in your calculator. 1 divided by the tangent of 28. I have no idea what that is, so I'll do 1 divided by the tangent of 28. And did everybody get 1.9? Because they rounded, I guess, to 10th place again. Did y'all get 1.9?
Yes, ma'am.
Okay, so W equals 1.9. Yes. Are y'all cold?
No.
It was just so hot in here earlier. We'll turn the heat back on in just a minute. All right, let's do another one. because we need a little bit more practice. That doesn't look much like a right angle, but it's supposed to. I have 33 degrees and 4.5 and my W. So the first thing I have to do is figure out sine, cosine, or tangent. Well, sine would be the opposite. Do I have that? No. Cosine would be adjacent over hypotenuse. Do I have that? Yes. So I'm going to use the cosine of 33 equals the adjacent over my W, over my hypotenuse. 4.5. Oh, I said that backwards. I'm so sorry. I did say that backwards. Thank you for catching that. It would equal the adjacent W over the hypotenuse. 4.5. Is everybody good with that? Thank you, Will. Then what do? We don't know. How do you solve for W? You're either doing the switch, you're either switching it or you're multiplying. Which one are we doing? Multiplying. It's going to be one of those two things, okay? So we multiply by 4.5, and then we'll get our answer. We'll get our W. So I'm just going to plug all that in my calculator, this right here. 4.5 times the cosine of 33. 4.5 times the cosine of 33, and I get 3.8. 3.8. Okay, let me make sure. Yeah, I'm good with that. So this is like 4, 5, 6, and 7. So y'all try those 4 problems. Yeah, I think you round to the nearest 10th, just like we did. Okay, round to the nearest 10th. So y'all can compare. Make sure you use the right trig function, sine, cosine, or tangent. You already.
8, 9, and 10 questions.
Y'all, we're gonna do numbers, I guess 8 and 9 together. That means I'm gonna give you credit for it, but you have to what? Write it down on your paper so you can get credit. You would draw a picture because it's geometry and pictures help a lot. You're just drawing a right triangle. It says there's an escalator at a shopping center and it's 200 feet 9 inches. Okay, well, first of all, that's 2 different measures. I can't have 200 feet 9 inches. I just need to turn it all to inches. Here's my escalator right here. See, it's going up. Okay, but what's 200 times 12?
2,400.
Yep, and then we would add 9. So 2,409. 2,409 inches. Is everybody good with that? That's why we're doing this together. That's in inches how long this escalator is. What is it says it's at an angle of 15 degrees. Rises at an angle of 15 degrees. No, that's our little angle. Okay, right here. It's 15 degrees. Okay, is everybody good with that? So it's really small number. And then it says, what's the vertical rise? Well, this is vertical, right? That vertical means up and down. So how high up is this escalator going to go? All right, and it's going to be in inches. And it says nearest inch. That's what it wants our answer. So you have to decide sine, cosine, or tangent. And y'all were right. You're going to say the sine of 15 equals x over 2,409, 2,409. How would you solve for x? Yeah, multiply. So that 2,409 times the sine of 15, and it should be kind of a big number. What did y'all get? 623.5? Oh, I'm sorry.
Wait.
Yes.
623.5.
That's what I got. Uh-huh. I'll write it out, what you were supposed to multiply by. 2,409 times the sine of
Like the
15.
nearest inch means like.
Okay, so
623.
623 is really what it would be. Yeah, because the nearest inch. And anyway, that would be your answer. 623
Inches, right?
inches. Yes. Okay, then next we have, let's see what this other one is. Good, there's no measurement change on number 9. I'm going to draw number 9 down here. There's a 12-foot long ladder leaning against a wall. So kind of the same picture. This is a 12-foot long ladder, and it's leaning against this wall. And it makes a 77-degree angle with the ground. That's right here. I'm at the ground. So it says, how high does the ladder reach on the wall? That's this right here, correct? That's how high up it's going to go. We can figure that out. Again, you want me to let y'all have a second and see if you get it?
Yeah.
Yeah? Okay.
You did 72.8.
Let's see. I think that
I
sounds...
got 12 inches.
Yeah.
About it.
Yeah. They, and what does it say?
'Cause it was
Round to
like
the nearest, oh, it says round to the nearest inch, but we're in feet on this one. Well, let's just get in feet. All right, you got about 12 feet? Let's just get our answer in feet. Is that what you got? Was 12 feet? I
So
think
what
you're,
did you just
because
do?
it was in
Inches
feet. It was in
then?
feet the whole time. That's a 12-foot long ladder. Right?
Yeah.
Yeah, so you were right.
If you wanted to find your inches,
If you wanted to find your inches, you would have to take that number and, yeah, multiply by 12. Okay, what we would do is the sine of 77 equals opposite over hypotenuse. And I know they said inches, but I just want your answer in feet, because that's what I told you at the beginning. We weren't going to change our units.
I know what I did wrong this week.
You,
I did.
okay.
I accidentally wrote 17 instead of 77.
I actually wrote 71 because it was.
Oh, so what do we get? 12 times the sine of 77. And we should get, what, 11.7 or something? So it's really close to 12 feet. Okay, if you had that 11.7 to inches, you would just multiply by 12. And it's like 140. Okay, but we'll just say 11.7 feet, or about 140 inches, whichever way you did that. All right, now we're moving on to the next part. This is really our last question in our book, but we might can find some more problems on the back to look at. They have an inverse function. Let me draw a picture. They give us this triangle. They call it W, X, Y. This is 10 and this is 6. And it says, okay, they want you to find angle X. What is the measure of angle X? So you're going to have to pick which trig function. I don't know the angle, so I'm using the letter X for now, right? So am I going to use sine, cosine, or tangent? If I start at X, what do I have? The sine. I have opposite over hypotenuse. Is everybody good with that? So we set it up. We're going to put sine of X equals 6 over 10. Is everybody fine with that? It's basically what we did at the beginning of class, right? Now, though, it wants us to find the angle. If the question asks you to find a trig ratio, this is a trig ratio. It's a fraction, right? A ratio is what you can write as a fraction. I could reduce that, though, right? But it doesn't want us to find the trig ratio. It wants us to find the angle now. So it's asking a different question than earlier. So please know that. How you find the angle is you find the inverse. This is all a calculator problem. Once you set it up, you have to, basically if you were solving for X, what would you do with that sine function to move it? Well, you take the inverse. This is what you're going to do. Sine inverse of 6 over 10. Or if you had reduced it, that's fine. That's a calculator button. You would just type in, anytime you're looking for your angle, the sine inverse is the same button as the sine. See the little yellow button above it? On the sine inverse, you see that little yellow button above sine? So press second sine, that's sine inverse, and then type in your ratio, 6 over 10. And what does it tell us the measure of this angle is? Yeah, so you would round up. They want us to round up to 37 degrees. That's our angle. X is a 37-degree angle. Most of the time on angles, they want it as like a whole number. They don't want a decimal.
What number is it?
This is like numbers 11 through 14, but it's not any of those. Let me do one more. They have another triangle, and they say that this is X in M, 15 and 20, and they want us to find angle X again. So if I start at angle X, is this sine, cosine, or tangent? It's cosine, adjacent over hypotenuse. Y'all are getting good at that. So I'm going to write the cosine of X equals what? 15 over 20. Again, if it asked for a trig ratio, I would reduce that and that would be my answer. It's not asking for a trig ratio this time though, right? What's it asking for? The angle X. Find the angle. So what do? The inverse function. So in my calculator, I'm going to type in not sine inverse, but what? Cosine inverse of 15 over 20. And that's going to give you, and round it to a whole number. Huh? 41. 41 degrees is my angle X. Do we kind of get that? Yes. Do we need another one of those?
Okay, but these do the angles.
Yeah.
Like,
On 11, 12, 13, and 14, that's exactly what I was trying to find. I was trying to find this angle. Yeah, they just put it right here. They just said X degrees. They put it inside there. It's the same thing as mine in the book. They did write it a little different in the book. So you're looking for angle X.
Are we doing 13 being tangent?
Let me see. Yeah, y'all are doing 11 through 14. 13 is going to be, yes, tangent of X equals what? 17 over 11. Then all you have to do is take the tangent inverse of that number and it's your answer. So I'll give y'all some time to do those. Okay, they give us on number 15, this one is a challenging problem, that's why we're going to go over it together. They give us a rhombus.
Can you write this down?
Yes, y'all are going to write this for number 15. If I'm doing number 15, then you're doing number 15. Pictures are needed in geometry. Yeah, this is the picture I'm getting to. I'm explaining a rhombus. The diagonals of a rhombus bisect each other. This diagonal was length 7. What's half of it? Yeah, 3.5 and 3.5. This diagonal was a length 4. So what is that split in half? 2 and 2. It wants to know the angles of the rhombus. Okay? Let me make sure that's what it's asking.
This is I can't draw.
Find the measures of the angles of the rhombus to the nearest degree. It wants to know all these little pieces of these angles. How would we find an angle? Well, let's just start with this angle right here. How in the world would we find what that angle is going to be? Would we use sine, cosine, or tangent? Tangent. We don't know any of the hypotenuse. These are the hypotenuse. Okay? So the tangent of angle X, that little angle, is what? 3.5 over what? 2. So you would plug that in your calculator, the tangent inverse. Anytime you look for an angle, you must use the inverse of 3.5 over 2. And we'll just round it.
60.
What'd you get? 60? Okay, let me see.
Wait, how do you know when to do the inverse?
Whenever you're looking for an angle, that's when you have to do the inverse.
Oh.
Yeah, it is 60.
So you got 60? Okay, so they got that this angle is 60. Guess what this angle is going to be? 60. Okay? And if this angle's 60 and this angle's 90, what's this angle going to be? 30.
So what we were at in our answer.
So, and then this one's going to be 30. So your angles are looking like they're either 120 degrees, or you could just show all these, but really it's looking for this angle's 120, this whole thing, because your rhombus is really drawn without the diagonals. This is 120, this is 120, this is 60, and this is 60. That one was a little bit more difficult.
Can I go to the bathroom?
You may, but I am still going to do 17 and 18.
What's that?
120 and 60. Those are the two measures of the angles. Remember, a rhombus doesn't have equal angles, not like a square and a rectangle. Okay?
So you just do 8 equals 60?
Do it.
8 equals 60?
And 120. Your angles, or no, you're just trying to find the angles, not really x. I had to find x to find the measures of the angles. So they got 59 and 121, so they must have just rounded a tad bit different than we did, but 60 and 120, that's good. Now, let's look at number 17 together. If I'm writing it, then you're writing it. You're going to get the answer for this one. I have two different right triangles. That length is 5.5, 45 degree angle, 35 degree angle. They want me to find W, and they want me to find X. That's all written on your paper. How would I find W? That one's the easier one to find. You use your little 45 degree angle, so you're looking at sine, cosine, or tangent. The tangent of 45, they give me the angle, equals opposite over adjacent. 5.5 over W. How do you find W on this one? Yeah, you're going to switch. Normally, we've been multiplying, but every so often, we actually have to do a different problem and just switch them. So W equals 5.5 divided by the tangent of 45. So what is that? I'm going to find my W.
So we do that in our
So how would
Yep.
you do that in our calculator?
You would do 5.5 divided by the tangent of 45. Yeah, I think the tangent of 45 degrees is 1. You'll learn that in advanced math. So you get 5.5. W is 5.5. The only way to find X is to use our big triangle now and find the whole thing. I need to, because I can't just find this little piece. I have to find this whole side. When I find the whole side, then what would I do to find X? Okay, I can't just find X. It's a piece of a triangle. That's not even a right triangle. Okay, but can I find the whole length of this triangle right here? Yeah, and then if I subtract 5.5 from it, would that give me X, what it is left over? That's what we're going to do. So, okay, again, I used this little triangle. Imagine that little triangle's not there. Can I find the length of this entire big triangle? Yes. When I find the length of the big triangle, and I know the length of W, how would I find X? The big triangle minus W would be that little bit left over right there. Do y'all not see that? No? Yes? Look, if I draw this big triangle without the other one in there, and if I find the length of, I know this is, 35 degrees. Can I find the length of this whole side? Yes, I'm going to do that. Just go with me. I'm going to find the length of this entire side. What do I use? Tangent. So the tangent of 35 equals 5.5, and I'm going to call it y, because that's the length of the whole side, is y. So I would switch them. 5.5 divided by the tangent of 35. So this one's not going to be 5.5. What is that going to be? 5.5 divided by the tangent of 35. Did y'all get 7.9? Let's do 7.9.
35.
For the tangent of 35, 5.5 divided by the tangent of 35. That's 7.9. So this entire side is 7.9. Little w is 5.5. How in the world would I find x? 7.9 minus 5.5 is 2.4. That's how we would find x.
See, now, I didn't know what you were talking about.
Yeah, so sometimes they're going to have problems, and probably one like that on your test, or like number 18. Because of time, I am going to stop here. I won't do number 18. Hold on to your worksheets. Y'all are going to turn them in today. But just hold on to them for a second, and then I have something for everybody to help me with. Okay. So just hold on to those worksheets.